Request all of you to kindly settle down. We are about to start. Welcome back, everyone. I hope you got sufficient time to enjoy your lunch. We will start our second thematic session for the day, titled Methods and Metrics to Improve Nutrition Through Sustainable Agriculture. The co-chairs for this session are Dr. Nisha Arunatilake, who's a research fellow and the director of research at the Institute of Policy Studies of Sri Lanka, and a research fellow of the Partnership for Economic Policy. She has contributed to numerous national, regional, and global economic policy documents, research collaborations, and publications, and served in national and regional level policy committees. She holds a BSc in Computer Science and Mathematics with summa cum laude from the University of the South, the USA, and an MA and PhD in Economics from Duke University, USA. Welcome, Dr. Nisha. Our second co-chair for this session is Dr. Mugdo Mehzab, who is an associate research fellow with the Poverty, Gender, and Inclusion Unit in IFPRI based in Dhaka, Bangladesh. He's a development economist with research interest in environment, health, and political economy. Prior to joining IFPRI, he was a postdoctoral fellow at Stanford Graduate Business School and Stanford Woods Institute for the Environment, Stanford University. He received his PhD in economics from the University of Virginia. He also received the US Fulbright Scholarship from Bangladesh to pursue masters in policy economics at Williams College. Welcome, Dr. Mehzab. I hand it over to both of you to run the session.
Thank you so much, Aisha, for the introduction, and I welcome you all to our session. Without further ado, let's get into business because we would like to stick to time. So I would like to invite our presenters for the first session. If you could kindly take a seat at the podium. MD Saiful Islam from Summit, Mohammad Wasik Faisal from Summit, Sujan Sapkota from Herd International, Sedian Bukaka from IFPRI, and Oliver Ecker from IFPRI. Thank you. I think we're missing Oliver. He's in the room. All right. Nisha, with your permission, shall we start? Or yeah, thank you. All right. I would like to invite MD Saiful Islam to give his presentation first. And please use 8 minutes. We'll be strict on time. Monali is keeping the time. She will wave you at the last 2 minutes and kindly finish by 8 minutes. Thank you.
Good afternoon. This is Saiful Islam from Summit, Bangladesh. Distinguished guests and esteemed colleagues, ladies and gentlemen, it is an honor to be here today, the important gathering discussing one of the most pressing challenges of our time, reducing carbon footprint of agriculture through sustainable agriculture and efficient practices. Agriculture serves both for contributor and victim of climate change. It significantly contributes global warming greenhouse gas emissions while also facing severe impacts from erratic weather pattern, floods, and droughts. The challenge is especially pronounced in Bangladesh, a country known as for diverse agroecological zones and vulnerability to climate change. Our study focused on conservation agriculture, especially conservation agriculture promotes for reduced tillage and also mitigates this climate change effect. Conservation agriculture minimum soil disturbance, cover cropping, and efficient nutrient use, offering the potential to reduce emission while maintaining agriculture productivity. Our study purpose highlighted the potential benefits of conservation agriculture, but its impact, greenhouse emission and fertilizer efficiency in conservation agriculture remain uncertain. That is why we study to evaluate the impact of conservation agriculture on crop yield, quantify the reduction of energy use and greenhouse gas emissions under the conservation agriculture system, to provide evidence-based recommendation for integrating sustainable practice to Bangladesh's agriculture framework. Now we're going to methodology. In this experiment was conducted in two diverse locations in Bangladesh, Jamalpur and Borishal. Jamalpur representing active Brahmaputra Jamuna floodplains, agroecological zone 9, and Borishal located in Ganges tidal floodplain in agroecological 14. Our implemented both conservation agriculture and conventional agriculture systems are tested treatments with varying combination of different type of fertilizer management, and also we conducted two types of agricultural practices, conventional agriculture and conservation agriculture system. To estimate the greenhouse gases, we use CCAP modes mitigation tools for estimate the greenhouse gas emissions and energy use as well as energy use efficiency. Result. In case result, our study findings provide strong evidence for benefits of conservation agriculture. Conservation agriculture yielded 5% increase in rice maize cropping system compared to conventional practice, demonstrating the ability of sustainably intensify production. In case of energy use, conservation agriculture reduced energy use 44% primarily due to reduced tillage and optimized fertilizer management. This highlights the potential of CA to lower energy footprint of agriculture production. Another things, global warming potentiality, CA practices resulted about 24% decrease greenhouse gas emission compared to conventional agriculture. Emission intensity, that means yield scale emission, a critical metrics, sustainable production was reduced 29%, about 29%, of indicating the more efficient use of resource in relation to output. This result underline cause the dual role promoting environmental sustainability and enhancing agriculture productivity, making it crucial strategy for climate resilient agriculture. Now I am going to implementation. This summary, our study demonstrates that conservation agriculture, which paired with effect of nutrient management, is a viable solution for decreasing the twin challenges, climate change as well as food security and nutrition security. By increasing yields, improving energy efficiency, and reducing greenhouse gas emissions, CA represent a sustainable path forward for agriculture in Bangladesh and beyond. However, the transition of conservation agriculture requires a collective effort. Policymakers must prioritize conservation agriculture for their agricultural strategies and over incentive farmers. Researchers need to further refine the conservation agriculture techniques to enhance their adaptability. Extension service and capacity building initiatives must focus on equipping the farmers with the skills and knowledge needed for successful implementation. The implication of the research extend beyond the environmental benefits. conservation agriculture can empower smallholder farmers, improve their resilience to climate shocks, and enhance the national food security. I would like to express my heartfelt gratitude to the conference team, my collaborators, partners, and organizations, funding agencies for their invaluable support this endeavor. Together, we can create a resilient agriculture future, not only for Bangladesh, but also for global community. Thank for your attention and welcome for questions and look forward to our discussion. Thank you very much.
Thank you so much. Thank you so much, Mr. Faisal, and thank you so much. I appreciate it that you finished within time. So I'd like to invite the second presenter, Mohammad Wasiq Faisal, for his presentation. Thank you.
Thank you. Good afternoon, everybody. So welcome to today's conference on delivering for nutrition in South Asia, connecting the dots across systems. My name is Wasiq Faisal. I am working as a research associate at CIMIT, based in Dhaka, Bangladesh. Today, I am going to present the results from the on-station trial on enhancing nutritional yields through effective efficient crop diversification, a comparative study of rice system in Bangladesh. So Bangladesh is a highly populated country. It is self-sufficient in rice, but not for other crops. Overall food security is a challenge. In addition, malnutrition is prevalent. Over the past 2 decades, Bangladesh has made significant steps in food production, particularly in rice, which remains the country's primary crop. Challenges in major food production, like stagnating yields, overuse of resources, and environmental degradation of water, soil, and greenhouse gas. Also, Bangladesh is one of the most vulnerable countries to climate change. Considering all these challenges, there is the need to accelerate the transformation of our agri-food systems to strengthen their resilience through diversifying cropping systems and ensure that healthier diets are affordable for and available to all. We demonstrate an approach to examine trade-offs and synergies among these objectives for a complete cropping cycle for 1 year in the northern part of Bangladesh. We estimate the profitability, counting the total production cost and market value, nutritional yields for carbohydrate, protein, fat, including micronutrient, iron, zinc, and vitamin A and C. So the Regional 1 CGIAR initiative, TAFSA, focuses on farm and landscape level research to promote resource conservation and ecological services. Therefore, strategies for enhancing profits and nutritional yields through interdisciplinary approaches, facilitating the implementation of research recommendation through extension network and supportive policy reforms. This research study includes assessing the nutritional yields of diversified alternative cropping patterns and compare them with the farmers' common practices to identify the most beneficial options in the northern part of Bangladesh. This experiment was set up in randomized complete block design with 9 scenarios and 3 replications. The scenarios were 9 alternative cropping systems and integrated of non-rice crops during winter and spring seasons to evaluate the nutritional yields and profitability. In Kharif 2 season, treatment T3 to T9, all among rice is biofortified varieties which are major sources of micronutrients, especially for zinc and iron. We measured all agronomic data, including crop phenology, cost of all inputs and outputs, labor data, and amount of irrigation water applied. Nutritional yield was calculated with established nutritional factors of edible yield of respective crops as a measure of nutritional value of the production. So the treatment selection for this experiment, all these cropping patterns were chosen through a participatory focus group discussion involving about 50 farmers' households in 3 different locations in the northern part of Bangladesh. Farmers ranked various cropping options, including their most common practices. These patterns were then compared against the common cropping pattern used in the region. This method ensured that all chosen cropping systems reflected farmers' preferences, increasing the likelihood of adoption if the trials proved successful. T1 and T2 are the farmers' practice, and T4 is the modification of T1, and the T5 is the modification of T2. So this is the statistical analysis. The preliminary findings after the first full cropping cycle All diversified cropping systems, T3 to T9, outperform the most common farmers' practices over T1 and T2 in terms of rice equivalent yield and net profit. Up to 30% more rice equivalent yield is recorded, for example, by adding the leafy vegetables between two rice crops, T4 versus T1, and or by intercropping the same vegetables with maize, T5 versus T2. T4 and T5 shows best rice equivalent yield compared to other treatments. Sweet corn, groundnut, and carrot have a high market value, but farmers need to add market system development. In case of nutritional yield, preliminary findings are diversification of cropping patterns contributes to the availability of vitamin A and C and micronutrients zinc and iron, mainly in Rabi season. Kharif 2 or monsoon season only scope for improving nutritional yields is biofortification. Carrot and some other leafy vegetables contribute to the vitamin A food security. Potato and leafy vegetables are good for vitamin C. So from the results, the rice equivalent yield was recorded significantly higher in both T4 and T5 treatment compared to the other treatments due to higher market price of vegetables. Maximum net profit was observed in the treatment number 5, maize intercrop vegetables, sorghum and almond rice because of higher production of maize and vegetables. Potato, sweet corn, almond rice, this is the treatment number 3, showed the second highest net profit due to the high market price of sweet corn. The lowest net profit was recorded from the traditional system, T1, rice system, which was 2.5 times lower than the treatment number 5. All diversified cropping patterns, T3 to T9, contribute to the availability of vitamin A and C and micronutrient zinc and iron. During Kharif 1 growing season, the treatment number 3, sweet corn, treatment number 6 for groundnut, instead of maize for treatment number T7 or T9 increase extra rice equivalent yield. In case of labor, almond, potato, sweet corn, the treatment number T3 showed to be more profitable than the business as usual cropping pattern over treatment number T1 and T2 without need the more extra labor. So the net profit increased from over 1,400 in T1 and 2,400 by adding a leafy vegetable napashak between two rice crops in T4 and increase from more than $1,700 in T2 and moreover $2,400 by intercropping the same vegetables with maize and adding a fodder crop T5 instead of fallow during the Kharif season, Kharif 1 season. So for the implications, adding a leafy vegetables is an intercrop to maize or a sole crop between two rice crops is not an expensive investment in terms of additional production cost. Selection of leafy vegetables dependent on the local market and consumption pattern that influence the profitability of the Rabi maize crop. Overall, it can be concluded that vegetable-based systems are superior in almost all aspects of a traditional rice system. The findings indicate notable variation in productivity, nutritional yield, and profitability among different cropping patterns after one full cropping cycle. However, conclusions remain premature, require further data from multiple cropping year. Additionally, an analysis of the environmental footprint in each cropping system is essential for recommending optimal practices in sustainable agriculture. So I would like to give thanks to colleagues from BWMRI, especially Dr. Akbar Hussain and Dr. Mahesh Kumar Gatala from CIMIT, and Dr. Timothy Krupnik for his overall guidance and suggestions. Thank you all.
Thank you so much, Wasik Faisal. Thank you so much again for maintaining the time and giving a nice presentation regarding Bangladesh. So from Bangladesh, now I would like to move to Nepal, and I would like to invite Sujan Sapokta, Project Manager, HERD International, to give his presentation. Thank you.
Good afternoon, everyone. I am Sujan Sapkota, representing HERD International, and my presentation is on pollinator decline, threaten the nutritional health and livelihood of rural Nepal. Starting with background and rationale. In the right side, you can see the picture, the agricultural landscape of Nepal, where 84% of all farms are smallholding, which are highly reliant on local agro-ecosystem services, and 3/4 of crop species are dependent on pollinators who pollinate different flowers to transfer pollen grains for fertilization and crop yield. And pollinator decline is one of the major threats in the region. Food insecurity and malnutrition are very high, and the existing health system and agriculture system are extremely vulnerable to climate change and environmental degradation. So in this study, we want to answer 3 major questions. First, what are families eating and which crops provide their key nutrients? Second, which insect pollinate these crops? And how will climate change and other stressors impact the system? From these 3 questions, we want to answer how can we safeguard and enhance human nutrition and livelihood through pollination management. This study was done in Jumla district of Nepal, a very remote district, 10 study villages. Moving on to methodology. Methodology have 2 components. One is nutrition survey and another is ecological survey. First, nutrition survey. What are people eating throughout the year? We want to know what are people eating throughout the year and what is their nutrition status. Fortnightly dietary recall surveys, 24-hour dietary recall survey using 5-stage multi-pass method, and food models for portion size estimations were used, and 15,687 dietary recall survey were captured from 800 participants, 200 households from 10 study villages. Moving on to ecological survey, plant pollinator vegetation survey was done, and 11,000 plant pollinator interaction were recorded, and pollinator exclusion experiment where we compared the open pollination, and if we exclude the pollinator component, we measured the crop yield from 4 major crops: apple, slipper gourd, jumli beans, and pumpkin. So moving on to results. Comparing local versus imported source for nutrient intake in the region, most of the micronutrient intake comes from locally sourced food, and in the nutrition and for those food, if we go to the pollinator dependent crop, and pollinator dependent crops are very important for the nutrition intake of different macro and micronutrient, especially vitamin A, folate, vitamin A, and fat. So from this result, we can see that pollinator dependent crops are very crucial for the nutrient adequacy of the region. And from this study, we found out that key pollinators like honeybee species, bumblebee species, hoverfly species, and solitary bee species are crucial for those crop production and for the nutrient adequacy also. And from the experiment, we found out that comparing with open pollination and pollinator exclusion experiment, we found out that yield in apple decreased by 94%, in slipper gourd it decreased by 90%, yield in pumpkin decreased by 84%, and in jumli bean it decreased from 16%. That's why we know that pollinators are very, very important for those crops. And when we see the pollinator change impact, if we remove the pollination component, then we predicted that 44% there is 44% decline in household income, 23% decline in vitamin A intake, and 21% decline in folate intake. Whereas if we enhance pollination services, then we can achieve up to 15% increase in household income, 9% increase in folate intake. Therefore, to enhance pollination services, the forage availability of those important pollinators are very, very important. And this wild plant, in Nepali we can say, this specific wild plant in the region, Dhatelo, Karausi, Ghangeru, Saipatri, are very important for those pollinators. Not only crop flowers, but also wildflower are very important for their food availability of those pollinators. And to conserve these pollinators, these wild plants are very, very important. Moving on to implication and pathway to enhance health and biodiversity through different agroecological intensifications like biological pest control, soil nutrient management, water regulations, soil health management. Pollinator management is free, but we have to manage pollinator management approach. We have to act now by increasing forage availability, enhancing nesting habitat, preserving the nesting habitat, and beekeeping promotion is crucial, along with other social and behavioral change for nutrient food intake can only achieve enhanced nutrition and biodiversity. This is the study team. The project was funded by Belmont Forum, and ecological team was led by Bristol University, and nutrition team was led by University College London, and Hard International implemented the study in the Jumla district of Nepal. It was a 3-year interdisciplinary project studying the link between pollinators, human nutrition, and climate change in the rural Nepal. Thank you very much. If you have any questions, please feel free to ask. Thank you.
Thank you, Sujan, for your excellent elaboration. I appreciate that for being on time. I'd like to invite Sedian Bokaka for providing evidence from India and Vietnam now. Thank you.
Good afternoon, everyone. Thank you very much for having me. So I'm Sedian Bukaka, Research Coordinator for IFPRI, based in Nairobi, Kenya, and I will talk about the contribution of nature-based solutions to food security with evidence from India and Vietnam. So this is a study in collaboration with other IFPRI colleagues, Carl Radzari and Christine Davis, and it is based on the results of our baseline surveys in India and Vietnam in the context of the CGIAR initiatives on nature-positive solutions. So some of you may know that this initiative aims to reimagine, collaboratively create and implement nature-positive solutions for agri-food systems that equitably support food and livelihoods and ensure that agriculture is a net positive contributor to biodiversity and nature. So the baseline surveys were carried out, of course, as a first step in order to evaluate the impact of the program in Vietnam and India in the areas interested by the program, so in Ahmednagar and Nandudar in India, and Sapa and Mai Son districts in Vietnam. And for both countries, we had sample size of around 1,200 households. So this slide really was trying to depict the nexus between the intensity of adoption of nature-based solutions and food security, but I will not dwell on it. I think the presentations that came before me really emphasized that, the importance, of course, of improved soil health and increased biodiversity for food security. And so in the survey, we collected data to compute variables related to food security, and in particular, income, food expenditure, crop and livestock productions, crop yields, data related to crop diversity. We, of course, also collected data on food consumption and nutrition, with a caveat here. This was not a nutrition survey, so not to the standard of nutrition specialists and experts in the room, more in line with multi-topic household surveys of the like of LSMS, etc. Another point also is that in the areas surveyed in India, some cultural norms favoring vegetarianism led to underreporting of meat and fish consumption. So to ensure cross-comparability, across countries, the food indices here exclude meat and fish. So just first about adoption of nature-based solutions, we had a list of up to 48 practices, depending on the country. And what we see for India and Vietnam, on your left here are the top practices, including intercropping and crop rotation, but also zero minimum tillage in India. And in Vietnam, manure fertilizer, use of preparation of bands and terraces to control erosion, use of selective pesticides, but also the growing of local land races of trees. And so on average, we had households practicing around 5 solutions in Vietnam and 1.4 in India. And what we were able to do is to classify the households based on intensity of adoption. So from non-adopters to high adopters, with around 42% of non-adopters in India, 42% of low adopters, and 15% of high adopters. While in Vietnam, we had, I can't really see with that color, I'm sorry, but I think the non-adopters were around 20-something%, low adopters 42%, and high adopter 31%. So what we want to do now was to look at indicator of food security disaggregated by these 3 types of adoption intensities. And to do that and to go beyond averages, a useful tool is to use cumulative distribution functions to be able to compare 2 different types of distributions. So, very sorry for this very cluttered style slides here, but basically what you have is a series of cumulative distribution functions, or CDFs, for indicators of calorie consumption, fat consumption, and carbohydrate consumptions for Vietnam on top and India below, for our 3 adoption intensities. So let's imagine that we have only really one graph here with our CDF. So let's imagine we focus on the bottom left graph on calorie consumption for India. Basically, the light blue and dark blue lines represent our non and low adopters, while the red line represents our high adopters. And what the CDF tells you, and it's a little bit counterintuitive, but if your curve is consistently lying below, so curve A below curve B, it means that you are outperforming, or your distribution is better off than the distribution B. And so if we look here now at all our CDFs, what we see is that our high adoption curves, so the red for India and the orange for Vietnam, are consistently lying below the light and dark green and blue one, so the low, the non and medium and low adopters. So what we have is that high adoption is correlated with higher average food consumption and macronutrient consumption. We also wanted to go beyond just food consumptions, and we looked at diet diversity, and what we see is also an association with higher diet diversity for high adopters and less diet deprivation, here using the reference diet deprivation index, which is a fairly recent index conceptualized by some IFPRI colleagues, including here Olivier Eckert, that will present after me. So we also see that we don't have productivity trade-offs when using nature-based solutions. So we have a lack of difference in yields between high, non, and low adopters. So using nature-based solutions is not, can support productivity without relying on environmentally unsustainable inputs. Okay, and so we looked at those descriptives. What we wanted to do is also run some regressions to have some more robust association and correlation results. So we use 2 models, a very simple multivariate regression, but also a multivariate treatment effect. And what we see for both models, but let's focus on model 2. So it's down, yeah, on the bottom. I'm not sure you can see. But basically what we have is across the board statistically significant results in terms of food consumption and less diet deprivation for high adopters. So with the pooled data, Vietnam and India, we have 14% more calorie consumption, 25% more fat consumption, 11% more carbs consumption, and 8% less diet deprivation. So very quickly, the conclusions, I think, here were quite clear. My time is up. I just wanted to finally tell you that the data are available, open access of this study on the IFPRI Dataverse. Thank you.
Thank you so much, Sadie. Thank you so much for your presentation. All right, last but not the least, I would like to invite Oliver Aker from IFPRI to deliver his presentation. Oliver, you have 8 minutes. Thank you.
Good afternoon, colleagues. So first of all, I would like to invite those colleagues who are sitting in the back maybe to move to the front and perhaps take the open seats, then you may see the slides a little bit better. So what I will talk about is a study that is a little bit different to the previous studies. So my study is big picture, it is, has an economic focus, it relates to modeling, and it has a strong policy focus. So it's on diet quality and sustainability effects of agricultural value chain growth. It's a simulation analysis which we will then apply to data on rural Bangladesh. It's a study together with my IFPRI colleagues, Andrew Comstock, Alan de Prauw, Chen Dao, and Rahul Talukta. Next slide, please. Oh, no, I have it. Okay, perfect. Sorry for that. So the motivation is, I think we all agree that agriculture and agriculture policy can play an important role for transforming food systems and delivering for nutrition. One of the main reasons is that agriculture is one of the largest economic sector in many Southeast Asian countries. But not only that, I think agriculture has also a direct link to food consumption. The graph that you see here on the right-hand side shows a measurement of the food system expressed in economic terms, and you can see that agriculture kinds of contributes here in Bangladesh about 8% of total GDP. But if we consider the entire food system, so the sectors upstream and downstream agriculture activities directly related to agriculture activities, that share is significantly larger. Now, agriculture policies can influence food systems and food processes, but the purpose of many of these agriculture policies is to influence the food system and food consumption more from the supply side. And the intention is that through improved food availability and food access, household consumption will also improve. But that is, of course, a fairly strong assumption, because certainly policy-induced changes, let's say in relative food prices, can go both ways, right? So you can think about prices that increase the food consumption, especially if we think about reducing prices of healthy foods, but you can also think about a situation, let's say a strong promotion of staple foods, where you have a situation that more income is concentrated in staple foods and people consume less and more healthy foods. And that is where the main motivation of this work comes from. Now, I would also argue that, especially in agriculture policies, consumer behavior is often insufficiently considered in agriculture policy making, but in fact it is key for the policy's impact on household diets, and by that on nutrition outcomes, but also on the environmental footprint of the different diets. So our study tries to address a knowledge gap that centers around two research questions. The first one is, how effective are alternative agriculture policies options, so policy options that policymakers have in front of them, on diet quality for households? And another question is, do healthy diets mean automatically greater environmental sustainability? Or how large are the trade-offs between improving nutrition and health impacts of a better diet? And obviously, household food choices matter not only for the nutrition outcomes of the household members, but also matter for the environment. Now, the objectives of our study are as follows. So first of all, I would like to introduce a simulation modeling framework that is there for the ex-ante assessment of the impacts of government sector policies, specifically agriculture policies, on dietary outcomes, and also on environmental outcomes. The purpose is, of course, to help governments in their policy decision-making by providing evidence for this. Then the next step is that we apply the modeling framework that I will present for simulating the effects of economic growth. This economic growth will be driven by different agricultural value chains on the diet quality of households and the environmental sustainability. As I have pointed out, we focus on Bangladesh and specifically on the effects among rural consumers. We use household panel data from IFPRI's Bangladesh Integrated Household Survey. The graph on the right-hand side, that diets in Bangladesh and especially in rural areas are poorly diversified, but over time, along with economic growth, they have somewhat improved. Now, let me talk a little bit about the simulation modeling framework. It has to some extent 4 components. The first one up front is a RIAPA model. At the center of this RIAPA model is a dynamic, recursive, country-specific computable general equilibrium model. From this CGE model, we derive changes in household incomes for several household groups, and we also obtain food price changes for roughly, I believe, 50 plus food groups. These shocks, as we call them, enter then a microsimulation. That is the blue boxes that you can see here. In this microsimulation, we combine these economic shocks with income and price elasticities. Income and price elasticities are a measure of food preferences. So we do not only look at income preferences, but also at relative preferences and substitution changes. We use these shocks then in order to obtain simulated food consumption from observed food consumption and finally dietary outcomes. We have several simulation scenarios. You see the selected value chains that we will model on the right-hand side. So the scenarios are designed in a way to increase total economic growth by 1% over the baseline scenario over a period of 5 years. Now, let me come quickly to the results. So what you can see here is a ranking of the value chains that we modeled, and it shows you the impact on diet quality. According to our study, poultry and eggs had the highest positive effect on diet quality over the entire diet in rural Bangladesh. And cash crops like sugar, tea, and coffee, in fact, have a negative effect relative to a baseline scenario. So that is the impact on diets. Now, let's have a look at the impact on water and greenhouse gas savings. So important here, the main message is that there is no silver bullet. That's kind of the key conclusion. You will see that all these different value chains have partly positive, partly negative effects on greenhouse gas savings or water saving. Obviously, paddy rice has the highest negative effect, again, relative to the baseline scenario on water and greenhouse gas emission. Perhaps the only value chain where we see relatively stable effects on water and greenhouse gas saving is pulses and groundnut consumption, and here we have also a modest dietary effect. Given that I have not much time left, I don't want to discuss too much about the decomposition of our simulation effects. The main message is that the results are primarily driven by price effects, so market effects, not income effects. That is very important. And we do consider both own and cross-price changes. So let me come to my conclusion. I think the first conclusion is that the patterns of agriculture chain growth does matter for dietary as well as in the environmental footprints of the diets that are consumed. Of course, also the consumer preferences, so the consumer response to these shocks does matter. As I have pointed out, there's no silver bullet. And another important conclusion is what I presented here was a study on rural Bangladesh. The approach that we are using can be easily applied to other countries as well. Thank you very much for your attention.
Thank you so much, Oliver. Thank you so much. So we have time, I think 15 minutes, and I would like to 10 minutes. Okay, thank you, Aisha. So we have 10 minutes. So if you have any questions, please, just like the first session, if you could kindly queue up in front of the mic and introduce yourself, and please keep your question brief. Thank you.
Thanks. Yeah, this is Shailendra Kumar from ICRISAT. My question is to the last presenter. So first, that simulation model you have used, what simulation model you have used, and how do you validate that model? At what level of data you are using that validating the behavior of model? And then you said income effect you are not including. So without income effect, means you still continue to work on that? The 3 points. Thanks.
So let me.
I think we will collect the questions and come back to you. So any more questions from the audience? Please go ahead.
I just wanted to link the first two presentations to the third one, that quality of, so not just the nutrition component, but also food quality is majorly linked to the way we do production, right? So when you're looking at different practices for new cropping systems, how much are we looking at, say, input of agrochemicals? Does that increase, reduce? Do those practices also affect food quality in terms of the production or not? Is that something that's generally assessed when you do your agronomic trials and assessments? Thanks.
Thank you. That was Treya from IMI. Any other questions? Please go ahead. I'll take one more after this and we'll then check if there are questions from online.
I have a question to speaker 4. Actually, she explored the effect of NBS on the status of the food security. My question is very straightforward. How you can measure the status of food security of the households? Because this measurement is very much related with the intervention like NBS. Thank you.
Thank you. Any more questions from the floor? If not, artists, could you kindly check if we have questions online? All right, excellent. So we have a good bunch of questions, and I'd like to start from Oliver, and I think, yeah, in that way, yeah.
Thanks a lot for your question. So straight to your last comment, income effect is of course considered. Of course, we also consider own and cross price effects. Which simulation model we are using? We have a micro-simulation model that, as I explained, is driven by the income shocks and the price elasticities and income elasticities, so the response of households to income and price changes, and we use this to obtain simulated food consumption from observed food consumption. From the simulated food consumption, we then derive the dietary outcomes.
Please.
Thank you so much. So I think that was the last question. And of course, food security indicators are related to the type of, agricultural system that you use, including nature-based solutions. So at this stage, we cannot talk about proper, causal inference and causality. In this case, we are running a baseline. The follow-up is scheduled soon. But we did use regression models to control for multiple socio-demographic variables as well as geographic variables, etc. Yeah.
And then I think there were a question for the first two presenters.
Can I speak?
Go ahead, go ahead.
Question was not directed to me, but I want to say one line. In front of this agriculture and nutritional experts and policymakers, we have the evidence of pollinator decline. We have the evidence of how to preserve and conserve these pollinators. So we have to act now so that it will be too late in the near future. It's free for now, but it can be a big problem in the near future. Thank you.
Please, Sujan. Yeah, please, 30 seconds each if you guys want to comment on the question you had. I think there was a question regarding agro quality of the food.
Agro quality is not a concern. Food.
All right, then thank you everyone. I'd really like to thank our presenters, and thanks for the question. I would like to hand over to Dr. Nisha for the next session, next set of presentations.
Thank you, Mazhab. We now move on to our rapid fire presentation. So without much ado, let me move to the first presentation. It's an in-person presentation. Mohammed Monirul Hassan from Bangladesh. The floor is yours.
Good afternoon, everyone. My name is Dr. Mohammed Monirul Hassan. I'm a country advisor of Global Alliance for Improved Nutrition Gain. I'm presenting the foresight analysis of the diet transformation in Bangladesh, which is a scenario simulation study for the period 2022 to 2050. So it is studies supported by the Foresight Food Initiative under the Netherlands and IFPRI funding, and also Oxford University and the Wageningen University's joint work with the Global Alliance for Improved Nutrition. So what is this all about if we go for this foresight analysis? So standing today, so we are going to actually understand what the diet of 2050 is all about. Next slide, please. So the diet transformation study is a kind of comparing. Yeah, thank you. So the diet transformation study, it accounts for 3 types of different diets. One is the Eat Lancet diet, and as the Bangladesh food-based dietary guideline, and another is the business as usual. So what does it really mean? So we are comparing based on the current data about the future. So it says about, like, right now the Bangladesh as usual diet is more of cereals consumption and also less on the fruits and vegetable and animal source protein. But if we do nothing, in 2050 it will be like more of animal source protein and very low on the fruits and vegetable, and also low in calorie. But does it really help to reduce the health and environmental cost? So if we follow the other 2 diets, especially the Lancet diet as well as the food-based dietary guideline diet, it shows that the food-based dietary guideline and the Lancet dietary guideline shows the similar types of results. And the similar types of results produce like less of calorie, like from the cereal, but high on the fruits and vegetables. So it implies that the diet has changed, but with the Bangladesh food-based dietary guideline has more on the implication of the animal source protein, which has high implication for the policy to change the diet from these to the 2050. Thank you very much.
Okay, thank you very much, and sorry about the technical glitch there. Let's move to the second presenter, Anurag Banerjee, also in person, but from Bangladesh as well. Yes, please. The floor is yours. Is this working? Susan.
Good afternoon, everyone. So essentially, there's a policy push in Bangladesh where they are driving away from diesel-based pumps to electric and other alternative energy source pump. And also simultaneously, they are also looking at sustainable ways in improving their paddy-driven, paddy-dominant agriculture systems. So in this context, what our study is trying to investigate how this transition from diesel to electric influence the cropping patterns, and also try to look at various pathways, and also try to unpack this relation because it's fairly underexplored, and also like to contribute to the larger the literature of determinants of crop diversification. Now, in this, we use BIHS 3-year panel data, and we find that across the last 10 years, there has been a significant increase in number of electric pumps, and is also fair bit of decrease in the number of diesel pump use. But in overall, if we see, the adoption of electric pump has notably transformed the cropping patterns, and there's a marked shift towards winter-based paddy, and also which we can see is around like 7% percentage point increase, and also we see a dip in the non-paddy groups, which are nutrition rich, which includes like high value crops such as spices, vegetables. So the moral of the story here is that if we have to look at policy insights as the government is pushing, that the cheaper irrigation, like the electric, even though it is cheaper and efficient, but it has its own downsides. So yeah, I'll sum it up here.
Okay, thank you very much, Anurag Banerjee, for that insightful presentation. So let's move on to the third presentation, which is a virtual presentation. Is he online? Yeah, okay. So fathers are happy from also the studies on Bangladesh. You can do your presentation now.
Can I see my slide, or I should open my one?
Fardos, we cannot hear you clearly. Can you please speak closer
Yeah, I
to the
can.
microphone?
Yeah. So yeah, I want to talk about what drives the dairy farm food safety practices in Bangladesh. Evidence from PLS-SAM model, which is a partial least square structural equation model. So I'm from the University of Hohenheim. I didn't introduce myself, and I'm doing my PhD over there, and I'm also a faculty member in Khulna Agriculture University in Bangladesh. Next slide, please. Yes, actually, I plan to work in the dairy sector because the dairy sector is very important for nutrition, definitely. And I worked in with the farmers, dairy farmers in Bangladesh. We all know that dairy farmers is very resource poor in Bangladesh, and they're very small scale. I focused in one of my working papers that how the food safety structure is in the dairy farm, because the farmers are not very knowledgeable how to manage the farm in a hygiene way or clean way, because it's very important to maintain the milk production sustainability and also supplying the milk to the market so that the consumer can consume milk from the commercial market where the producers are not available to sell milk to them directly. So therefore, we found some causal influence from the farm and non-farm, I mean, from internal and external effect, and we found that farmer psychology, especially the knowledge and attitude, is very positively and significantly influenced to adopt higher and more cleaning farming practices in their dairy farm. But they have resource constraints. For example, they don't have the the cattle number is very low. It's not commercial farms, so they don't care about the hygiene in their farm. So therefore, it's important that to teach the farmer that if you want to improve your farm size, if you want to maintain a better livelihood with your farming, then it's important to make the resource in the dairy farm higher, and thereby it is possible to improve the food safety in the dairy farm and also the inspection of food safety
Okay,
by the
your time is up. I'm sorry.
Yeah, thank you.
Thank you very much. So let's move on to our the last presentation. It's from Mustafa Kamal. It's a South Asia-wide presentation. The floor is yours.
Thank you, Aisha. Okay, 1 second. So I'm Mustafa Kamal from CIMIT, Bangladesh, and today I'm going to present our study, which is optimizing agrobiodiversity for nutritional diversity. And this is a critical factor for enhancing the nutritional diversity and also the dietary diversity in this region of South Asia. So managing production diversity is at all level, like species, functional and regional level, is essential for sustainable food system. However, despite its importance, regional agrobiodiversity and its functional diversity pattern remains underexplored. And to address this gap, we developed a South Asian agrobiodiversity database for 2016 to 2021, covering the subnational level crop production data, dietary diversity indicators like minimum dietary diversity for women and household diversity, dietary diversity scores. And as well as with the food composition and nutritional data set across these 4 countries of Bangladesh, India, Nepal, and Pakistan. And using this data set, we calculate the Shannon Diversity Index and also applied global Moran for assessing the spatial clustering, and also applied optimized hotspot analysis to assess the crop production diversity and its functional diversities. So here our study revealed that in the middle figure, you can see that we found the most clustered crops are the non-food crops, and then afterward cereals and fruits. And the weaker cluster we found in spices and vegetables. And our hotspot analysis revealed that on the right side of the 4 maps, you can see the results. So we identified the varietal diversity, species level diversity, dietary functional diversity, and nutritional functional diversity at the bottom right sub-map. where we highlighted that despite of countries like Nepal and Bangladesh, their species diversity is very high, but yeah, functional diversity is low. So
okay. Thank you
we are
very
addressing
much.
these problems.
Thank you very much,
thanks.
Kamal. Sorry, I think we need to conclude to be
Yeah,
fair by
please.
everybody. This brings to the close of this session. This conference is on delivering for nutrition in South Asia, connecting the dots. So sustainable agriculture is very important dot in this, because without this, we can't have a variety of fruits and vegetables and grains and other types of fruit which will improve the diversity of the diets of the people and therefore the nutrition and food security. So today in this session, we learned that there are a variety, the agriculture is challenged by climate change, policies. In the example of Sri Lanka, even macro level policies affected the agricultural productivity. So in this session, we learned that still we have hope. There are so many solutions that can be used to improve productivity and nutrition and the diversity of the diet. So I hope the knowledge that we have brought together today will help us to translate that into policies to improve nutrition in the region. Thank you very much.
Oh, thank you so much. Yeah, I'd just like to thank our timekeeper, our note taker, and the organizer for hosting us such a great session. And thank you, presenters. And if you have any questions, please interact with the presenter and share your comments. Thank you.
Thank you to the chairs. You actually brought us back a little bit, not on time, but at least like a little bit back on track. So thank you for that. Can we have all of you for a group photo? In the meantime, I would just like to make a few announcements that we will have a 30-minute tea break. So we are again running 30 minutes late. So the session, the learning labs that were supposed to start at 3 p.m. will now start at 3:30 p.m. We have 3 learning labs coming up. One lab, the first learning lab, which will take place in this room, is on establishing nutrition surveillance system and analyzing longitudinal data. This is by BRAC University, Bangladesh. The second learning lab is on nudging for good real-time AI-driven diagnostics and behavior change to improve adolescents' diet and nutrition in Sri Lanka. This is organized in the room Saffron and Ginger, where the thematic sessions Bs were organized, and this is organized by Vayamba University and Fresh Sri Lanka. The third learning lab on transforming food systems for better nutrition, the power of fortification, which is organized by the UN World Food Programme, will take place in the Tamarind Hall, which is just next to the Saffron and Ginger Hall. So we take a 30-minute break, tea break, and be back at 3:30 for the learning labs. And after the learning lab, we'll have the last session for today, the plenary session on aligning actions across sectors to achieve healthy diets and nutrition goals, insights from Sri Lanka. So see you all in 30 minutes. Thank you, and thank you so much, chairs. Thank you so much. Please give a big round of applause to our chairs and the presenters.